Hello, my name is Matt from Houston MJ Associates, and this demonstration video shows how a Y501 with the semi-automated sample prep package runs a sample sequence. The system is running isopropyl alcohol as the solvent, and I will run a sequence consisting of a wash, a sample with 20 grams per deciliter water, and another wash. To begin, the sample sequence must be typed in. The system is now ready to go, so I will press start and ARV software will walk me through the sample preparation process. ARV asks me to put the dispense line into a waste file. Let's do that and click OK. ARV now asks us to place an empty wash vial under the dispense line. Let's do that and click Next. Vial 1 has been dispensed, so let's place it in position 1 on the autosampler. Next, ARV asks us to place vial 2 on the balance. It has finished tearing the vial, so now we will add sample to hit the weight target. Okay, ARV now asks us to place vial 2 under the dispenser. We'll do that and click Next. Vial 2 has been dispensed, so let's place it in position 2 on the autosampler. We'll also give it a quick mix. Now ARV asks us to place vial 3 under the dispenser. So we did that, and click Next. And now let's place vial 3 in position 3 on the autosampler. At this time, the user dissolves the sample, which can take 15 minutes or up to an hour or more to fully dissolve the sample. In our example here, all I had to do was quickly turn the vial upside down a few times to dissolve the water in the IPA. So in this case, I can go ahead and click Start to have the system inject and record the data for each vial. The operator can also leave the instrument unattended and come back later to view the results. But for the purpose of this video, we will stay to watch the system run the samples. So let me go ahead and click Start so that the system will run the samples. So the system has started to process vial 1. What the syringe pump is doing right now is just clearing the sample loop of the previous contents. And now the autosampler is loading the contents of vial 1 into the sample loop. And the system has started recording data. And the sample has just been injected. And so since this is a wash vial, we don't expect to see much of a change in the relative viscosity profile because there is no sample to increase the viscosity as compared to the solvent. So the viscogram should be completely flat, and we should get a calculated intrinsic viscosity very near 0. And the intrinsic viscosity is calculated to be 0.0002, which is what we expect. Now let me turn back over towards the autosampler so that you can see it as it's processing vial 2. So what's happening right now is that we're clearing out the contents of the sample loop. Okay, and the needle has gone down, and the system will now draw the contents of vial 2 into the sample loop. Okay. So let's pan back to the screen as the data system is about to start recording data. And it has begun to record the data, and the sample has just been injected, and you can see the viscogram having a smooth run up to a new plateau as the water sample is now registering on the transducer P2. And the calculated intrinsic viscosity for the sample was 0.014, which is what we expect. And so now the system is clearing the contents of vial 2 out from the sample loop, and will load the last sample, which is a wash vial, in position 3. Okay, the system has begun recording data for vial 3. And so what we expect to see is the intrinsic viscosity return to 0, since there should be no sample in vial 3, and there should be no carryover from vial 2. And the calculated value of the intrinsic viscosity was 0.0003. Of course, the viscogram didn't look very smooth because the scale was so zoomed in. So, but we saw what we wanted to see, which was that vial 2 had been cleared from the system. And so that is how you run a sample sequence using the Y501 semi-automated sample prep package. Thank you for considering our relative viscometer package for your analytical needs.